So if you haven't already watched question 3, it's a good idea to start with that. This one says, what is the pH and pOH of a solution with an H3O plus concentration of 5.72 times 10 to the minus 8 molar? Is the solution acidic, basic, or neutral? So before we find the pH, we can still determine if it's acidic, basic, or neutral. So since the concentration of H3O plus is less than 1 times 10 to the minus 7, because this is 5.72 times 10 to the minus 8, this is a basic solution. Okay, so we don't even need to do the pH. But we also need to know two other equations. The first is that pH equals the negative log of the H3O plus concentration. So essentially, the pH is a logarithm. Said another way, we're really looking at this number. Now, if this was 1 times 10 to the minus 8, the pH would be 8. Right? So we're just looking at the logarithm, or this number. Since this is 5.72 times 10 to the minus 8, this is going to be 7 point something, all right, as the pH. So this is basically just looking at the exponential space. Said another way, something that with a pH of 7 versus something with a pH of 8, the concentration of H3O plus is 10 times less because it's the log base 10. So this is how we can find the pH of the system, and the P of anything is the log of it in chemistry. So if we're looking here at finding the pOH, we need to know that the pH plus the pOH equals 14. And it's not a coincidence that the concentration of H3O plus times the concentration of OH minus equals 1 times 10 to the minus 14. This is essentially just the log of that same Kw equation. So the pH is the log of the H3O plus, the pOH is the log of OH minus, and the log of 1 times 10 to the minus 14 is 14. So this is just the log of that equation. All right, but it is kind of a separate equation. So in this case, we have pH equals the negative log of 5.72 times 10 to the minus 8 molar. And when you do that work, you find that the pH is equal to 7.243. Remember that I said it was going to be 7 point something, because if this was 1 times 10 to the minus 8, this would be 8. But because it's a little bit bigger than 1 times 10 to the minus 8, this is going to be 7 point something. Okay, this number actually goes down when this number goes up because of the logarithm. Now, if we look here to find the pOH, what we need to do is find that the pOH equals 14 minus the pH. And you could assume that this has as many 0.000s as you need in order to have the same number of decimal places as this. I should also note with the decimal places, because this is a logarithm, this is the exponent. This represents this number. So these 3 sig figs are all in the decimal place. Again, it's not 8 because this number is greater than 8, but this 7 represents this exponent. So when we do this, over here, we have the pOH equals, if you want, 14.000, you don't have to write it there, minus 7.243, and we find that the pOH equals 6.757. Remember we said earlier this was basic because this number is less than 1 times 10 to the minus 7, and when the H3O plus is less than 1 times 10 to the minus 7, it's a basic solution. Note that a pH of above 7, 7.243, also says that this is basic, or a pOH less than 7 also says this is basic. So these things are all related to each other, all right? We're just taking the logarithm of these numbers to simply make them more convenient numbers, all right? So that's basically what we're doing here.